Good morning, everyone. This is Madhubala, Assistant Professor from Vailtech Multitech, Dr. Rangarajan, Dr. Sakuntala Engineering College. So now we are going to look about computational thinking and problem solving. Here, first we are going to look about the algorithms. So what is algorithm? Algorithm is a well-defined computational procedure consisting of a set of instruction that takes some values or set of values as input and produce some values or set of values as a output, which is like algorithm is a well-defined computational procedure. It consists of a set of instructions and it takes some values as a input. Okay, it is defined as a sequence of instruction that describes a method for solving a problem, which is like we are giving input and that algorithm is uh, progressing and then it gives a output. So the properties here, the properties of algorithm, which is simple in English, precise and unambiguous. It should not like this come first, this comes second. That should not be there. Each and every instruction should be precise and ambiguous. The instruction in an algorithm should not be repeated infinitely. Same as like infinite number of steps. The algorithm should conclude after a finite number of steps. Also, it have an endpoint also. It derives results should be obtained only after the algorithm terminates. So the quality of algorithm, how should be the algorithms looks? The quality of good algorithms like it consists of time, memory, and accuracy. Time means some amount of time to take problem to complete the progress. To execute and program the computer system takes some amount of time. The lesser is the time required, but the better is the algorithm, right? In memory, to execute a program, the computer system takes some amount of memory. Is less than the memory required, the better is an algorithm. So it requires a little amount of memory to make a better algorithm. Here, the accuracy means it's a correct solution to given a problem. Like a multiple algorithm, it provides a suitable or correct solution to a given problem. Some of these may provide more accurate results than other, and such algorithm may be suitable for this. Here, the building blocks of algorithm is a statement. First, the algorithm, the diagram is statement comes first, and then state and control flow and functions. These are the building blocks of algorithm. Here, statements means it's a simple sentence written in algorithm for specific purpose, which is used for a particular specific purpose. A statement may consist of assignment statement, input-output statement, and command statement. Either it can be a assignment statement or input-output statement, or else command statement. First, the data is given, information given to the program. Then the process can be done with the help of input, and then it gives the output. These are the step-by-step process. Here I gave one example. First, the read the value of A. This is the input statement. And then calculate C is equal to A plus B. This is the assignment statement, which I am giving a assignment to that input values. And the final, print the value of C. So this is the output data. So A plus B is calculated and then the results will be stored in a C. That is print the value of C. These commands are given after slash lines, symbols, which is used to tell the purpose of a line. So I am giving the slash line. What is this for? So I am giving the slash line, which is used for the purpose of this line. The statement, which means a transition from one process to another process under specified condition within a time is called state. This transition form is one process to another process, from this to this, from this point to this point, which is called transition. An algorithm is deterministic automation for accomplishing a goal, which given an initial state will terminate in a defined end state. An algorithm will definitely have a start state and end state. The starting state and then end state. There is a state. And control flow. What is meant by control flow? Which means a given order is called control flow. The process of executing the individual statement in a given order is called control flow, which consists of three ways: a sequence, selection, and iteration. These are the three control flow process in this process. The sequence. Next, the sequence. All the instructions are executed one after another is called sequence execution. Example, I'm giving two numbers, sum of two numbers, like a start. Second one is read the value of A and read the value of B, and then it is calculated. Sum is equal to A plus B, and then print the sum of two numbers. Then I give stop. This is the description of a sum of two numbers. This is the sequence method. Next, a selection method. What is selection method? A selection statement causes the program control to be transferred to a specific part of a program based upon the condition. It is like a program should control be transferred to the specific part of program based on the condition. Either if condition is true, it performs some action. If the condition is false, it performs another action, like action 1, action 2. That only I gave. If condition is true, then perform some action 1. Else, if condition is false, then perform some other action 2. Here comes iteration. What does it mean by iteration? Iteration is a looping or iterating again and again, right? In some programs, a certain set of statements are executed again and again based upon condition test. That is, executed more than one time. It executing more than one time. Whether it checks the condition for comes to true. Basic structure of iteration. Repeat until condition is true. This is the point. Until it repeats until the condition is true statement. Example. Here I gave from 1 to n numbers. First point is start. We are going to start. Then read the value of n. Initialize I is equal to 1 as I as 1. Initially, I gave one first number. Repeated step 4.1 and 4.2 until I less than or is equal to n. So, I am repeating the fourth point, like print I and print I is equal to I plus 1. Okay. Next, a function. What do you mean by function? Function is a subprogram. A main method, a subprogram, and then in iteration, and then end process. What is a function? Function is a subprogram which consists of a block of code, which means a set of instructions that perform a particular task. For example, I'm giving a main function and then sub function. Okay, here comes addition of two numbers using function. So I am using two functions for additioning two numbers. Okay, here I have started with calling a function add with the bracket and stop. This is a main function. And sub function, which means, what does that means? Function add. What does that mean? First, we need to get the values. First point is step 1, function start. The second point, get a value A and B. Okay, then that is calculated and stored in a C. So add C is equal to A plus B. Adding the numbers from A and B to C. Then printing the values C. Then return. This is a function, main method, and main function and sub function area. Okay. Notation. Here comes a notation. There are 4 different notations of representing algorithm. So, how we are representing the algorithm is notation. 4 different notations to be represented in algorithm. Step form, pseudocode, flowchart, and programming language. So, these are the 4 different notations for representing algorithm. First, step form. What is meant by step form? A step is a step-by-step procedure for solving a task or program. The step must be ordered. That should be ordered and ambiguous and finite in numbers. It should be infinite, not infinite number of steps. It should not be there. It should be finite number. It is it is English like representation of logic, which is used to solve the program. Okay. Some guidance. I have given some guidance to writing some step form algorithm. It is like, keep it in mind that algorithm should be step-by-step process. Algorithm must be in step-by-step process. Then it should use begin and stop. Okay. For that, I gave begin and start to start the process, which includes variable and variable for their usage. How we are calculating the A and B, that should be stored in C, right? So including variables and their usage. Try to go back to step numbers if loop or conditions fails. If the condition fails, we have to looping. We have to iterate the process uh, when the condition becomes true. So I gave the looping or condition statements. Okay. The last one is use break or stop to terminate the process. So first we need to begin with the start process and end with the stop process. These are the step form in algorithm. So I have gave steps form algorithm for biggest among three numbers. So three numbers, among three numbers, I have to choose a biggest number. So step one, start. Step two, read the three numbers A, B, C. Compare A and B. If A is greater performance, step 4 else perform step 5. Compare A and C. If A is greater, output A is greater. Else output C is greater. Can you get my points? See, first compare A and B. If A is greater than, step 4, the else part has to be done. Perform step 5. Then compare B and C. If B is greater, output B is greater. Else output C is greatest. Then stop. Okay. This is another way. So read A and B. I have given three numbers. Read the three numbers A, B, C. Compare A and B. If A is greater, store A in maximum. Else store B in maximum. Actually, I have gave a maximum keyword to this format. And the last, stop. So this test code, see, algorithm for adding the test scores given as 26, 49, 98, 87, 62 and 75. So this method is used for adding these scores in particular value. So start sum is equal to 0, get a value and sum is equal to sum plus value. If next value is present, go to step 3, otherwise go to step 6. Then the output the sum. That's all. So, what is meant by pseudocode? Yes, the main topic, a pseudocode. What is meant by pseudocode? A pseudocode consists of a short, a readable, and formally written in English for explaining an algorithm. It is easier for the programmer or non-programmer to understand the general working of a program because it is not based on any programming language. Okay, it is this pseudocode. This pseudocode is basically a short, a readable format in English, which is not complicated, which is not American English, which is not should be in complicated. It's general English that can be easily understood by the programmer, also non-programmer, to understand the general working general working of a program. Okay. It gives as a sketch of a program before actual coding. So what does mean by pseudocode means? It gives us a sketch of a program. What is actually going to do in coding. Okay. It is not a machine readable. It is not machine readable, which is understandable by a programmer, also non-programmer. Pseudocode can be compiled and executed. Yes, pseudocode can be pseudocode cannot be compiled and pseudocode cannot be compiled and executed, which is like a skeleton of a sketch of a program. It is not a codable. It is not coding. It is this pseudocode is not machine language. Just a rough diagram for a program, how it should be, how the flow should be. That is, this is a short and readable format, right? It is not machine language. There is no standard syntax for pseudocode. What is meant by standard syntax? Like C program. In C program, we have learned hash include standard input output dot h. Like that, there is no standard syntax for pseudocode. Got it? Guidelines of pseudocode. How should be pseudocode? Okay. What are the basic guidelines of pseudocode? Write one statement per line. Okay. Capitalize initial keyword. Second, intent to hierarchy. Multi-end, multi-line structure. Okay, these are the guidelines of pseudocode. Basic common keywords used in pseudocode. I have given some basic keywords used in pseudocode. Begin, end, input, get, read, compute, calculate, add, subtract, initialize, output, print, display, if, else, indef, endef, and then while, end while, for, end for. These are all the keywords which is used in pseudocode. Begin and end, it is used for first statement and end statement. Input, get, ready. These keywords is used for inputting data. Compute and calculate, which is used for calculate the result of given expression. Okay. Add, subtract, and initialize. Used for addition, subtraction, and initialization. Output, print, display. It is used to display the output of the program. Got it? If, else, endef. Used to make a decision. If, else, this condition. If, endef, this condition. For that, this is using. While, end while is used for iterative statement. For, end for. Another iterative incremental and decremental testing automatically. Okay. The basic example for pseudocode. If condition, then statement 1 to be print. Else, statement 2 has to be print. End. Greatest of two numbers. Well, this is the syntax. And I am giving example for this. Begin, read A, comma B. If A is greater than B, then display A is greater. Else, display B is greater. Okay, this is a simple program. Whether A is greater or B is greater for that. Next comes flowchart. What is meant by flowchart? A graphical representation. We know basically what is meant by flowchart. This is a graphical representation. In Python, a flowchart is defined as graphical representation of a logic for problem solving. The purpose of flowchart is making the logic of a program clear in visual representation. This is the point, visual representation, making a logic of a program clear in visual representation. For this, flowchart is used. This is a graphical representation which is used for clear in visual representation. These are the symbol and symbol name and description. The straight line, which is flow line, used to connect the symbol. This oval terminal used to start, pause, or halt in a program logic. This rectangle, which is processing and represent arithmetic and logical instruction. A diamond symbol is used for as decision, represent a decision to be made, Circle, connector used to join the different flow lines. Okay. The rectangle with the line, subfunction, is used to call a function. And one more I have missed. I think this one is slanting of rectangle, right? Input, output represent the information entering or leaving the system. Okay. Next, rules for drawing a flowchart. What is the rules? Start, finish, and then come out from process symbol. Only one flow line should enter in a decision symbol. However, two or more flow lines may lead the decision symbol. Okay, if the input is coming for a condition, then it goes either with yes or no. Okay. Within a statement, first one is clear, neat, and easy to follow. A flow must have a logical start and finish. Only one flow line should come out from process symbol. The only one flow line should enter a decision symbol. However, two or three flow lines may lead the decision symbol. The last, within standard symbol, write briefly and prescribedly. Okay. Intersection of flow lines should be avoided. Here comes a control structure of pseudocode and flowchart. Here, this is a pseudocode and flowchart. What is meant by what we have learned Pseudocode is a simple and readable, which can be understandable by the programmer and non-programmer. For this, I have given begin, end, statement. This is a process. Here comes a flow chart, a sequence. The input comes for the condition, and then it's true or false, whether it is a condition is making the progress, and then end process. A binary selection example, I have given a binary selection example with pseudocode and flowchart. This is the if lights are green, then go, else stop. For this, I have given a flowchart too. S means go, no means stop. Pseudocode for multi-way and single way I gave, and multi-way also I have given. So control structure of pseudocode and flowchart. What is the control structure? Repetition in the sense a sequence of steps which are repeated a number of times is called repetition. For a repeating process to end, a decision must be made. Right, a decision is usually called a test. Pre-test repetition will be performed a test before any part of loop occurs. For that, post-test repetition, which is will be performs the test after the main part of a loop has been performed at least once, which is used to confirm the progress, will be performed at the test before any part of the loop occurs. Right. Control structure of pseudocode and flowchart continuously. Okay, pre-test repetition and post-test repetition. Here comes a pseudocode, a flowchart. Okay, while the question statement is, the statement is yes, it goes to next. If the condition is false, it goes to, again the process should be true. For this, I gave a pseudocode and flowchart for your reference. Post-test, this is pre-test and this is post-test. Got it? Here comes a light or not green, wait, and then end while. If the light is green, then goes for a final operation. Repeat until light gets green. Subprogram. What is meant by subprogram? Here we have seen that what are all the symbols we are using in flowchart. For this, subprogram is mentioned in square with the sublines. Okay, a subprogram is a self-contained part of larger program. Got it? A pseudocode and flowchart. Pseudocode, which is means a start car, engage geese, navigate car, stop car, end. Flowchart. What is meant by flowchart? A start car, engage engine, elevate the car, navigate the car, and stop car, stop. The flowchart. So pseudocode, which means what is the instruction? What are the instructions? We can understand by seeing this. What is meant by flowchart? The step-by-step process which goes flow. Okay. Programming language. So here comes a programming language. A programming language is a set of symbols and rules for instructing a computer to perform a specific task. A programmer have to follow all the specified rules before writing programs using programming language. The user has to communicate with the computer using language which it can understandable. Right. There are three types of programming language: machine language, assembly language, high-level language. So these are the three types of programming language. Here comes algorithmic problem solving. Understand the problem first. We need to solve the program that requires the formation of an algorithm for the solution. So we need solution, right? For that, a formulation of an algorithm should be there. First, we need to understand the program. And then computational devices. What are all the computational devices? Extract and approximate solution. The fourth one is decide an appropriate data structure. Then algorithm design techniques. Method of specify an algorithm. Specifying the algorithm. Proving an algorithm correctness. Analyze the algorithm. So these are the topics we have covered here. So we'll meet next video with the Unit 2 topics. Thank you so much.